everybody, you're watching Mr. Fugu Data Science. Today we're doing an example of natural language processing workflow or general workflow and the problems that can arise within your data. These data were obtained from the news API that we did in the last example. I just updated the data yesterday. So we need to talk about a few things. You need to understand the fact that if you're using stemming or lemmatizing, for instance, stemming is the case where you are just chopping off the endings of your words. You're not using any rule-based approach like lemmatizing. Now, this isn't always something you want to do. For instance, if you're in a circumstance where you're looking at the part of speech in like a news article or some kind of excerpt, you don't want to change the endings of the words, making something lowercase or affecting the punctuation, for example, because this will throw off the meaning of your sentence. Now, you're always going to have issues with things such as like spelling errors or conjugation. Sometimes people forget a space between a word, so you have two words together. Acronyms and abbreviations come up quite often, and these are issues that you have to figure out how to take care of. Now, for today, we have a lot of things that we need to import, so feel free to go on my GitHub, as well as, hit me up on any of the socials I provide in the link in the description below to keep up to date. Thank you to the recent subscribers and viewers lately, and those who have contacted me with specific examples that they would like to see in videos, or just general help. I really appreciate it, and it challenges me, so thank you. Let's look at two of these columns from our data set. The first one, which is on top, is the content column, which we'll be working with today. The description is of the same article, just a little bit different engagement, I would say. We need to notice a couple things, which was frustrating to me, that the articles were truncated on this web page to around 200 characters, which is very irritating for me. We have this bracket that we need to get rid of. We have this ellipsis that we need to either fix or negate that word. You can see that we have capitalization here, punctuation, conjunctions. For instance, we also have names of companies, and other areas of this file will have acronyms as well, or abbreviations. Let's get into the first thing of converting our data to lowercase. All right, what I did here was iterate through our column of content and use our word tokenizer, which will split our sentences. So the first thing that's happening is we need to consider inner to outer. So we're iterating inside of our looping variable. I just made some goofy looping variable where I'm converting each of the strings to lowercase, and then I'm removing the punctuation. All right. We're then using our string join and tokenizing our sentences and making those into words and appending that to a list and retaining each one of our 60 entries as a list of strings. We can look at the first entry here and notice a couple of things. Due to the fact that, let's zoom out just a little bit. Due to the fact that we got rid of punctuation, it removes the hyphen within 2 hour. We still have the plural form that we need to deal with the lematizer, for example. In these, we have the characters and the ellipsis that we'll also need to take care of, and any digits or symbols. So in order to do that, we can move on to the next step, which is the same code where we do a modification of taking our iterable and first replacing any of the hyphens with the space, then doing lowercase. Then we'll do our string punctuation and this addendum as well, which will be taking out any of our digits. And then everything else is the same. So we still have our stop words. We still have everything that's plural. We're not taking care of that yet. We only took care of this hyphen area, so now we have 2 words. And we got rid of the digits, but we still have the ellipsis. So let's move on to taking care of those now. So I iterated through the list that we just created, which was the update. And I'm doing a list comprehension and basically taking out any of the single character words which are useless and uninformative. Then I'm further doing a second list comprehension to take care of our stop words. Let's see what this looks like. This is telling us that we have, from the original data, 10% of that left, which allows you to see for this particular entry number 8 in our data set, we have 10% left after we get rid of digits, symbols, punctuation, etc. So if you notice, we're doing all right, but we still have these 2 we need to deal with. We got rid of stop words as well as any single letters. All right, we're doing pretty good. There's something I wanted to show. Since we're getting rid of useless words, let's get rid of that ellipsis and that other stuff. which I forgot, totally neglected to do. If you notice, now we don't have that junk anymore because what I did was take out the last two entries of each one of the list, which was the ellipsis followed by the chars, which are your characters, which were irrelevant. Let's do our lemonizer here to see what this looks like as an example I got from GitHub so we can get a little bit of a clarification. We have this sentence: the striped bats are hanging on their feet for best. Doesn't make sense, but whatever. So you see that these all look the same except it gets rid of the S on the bats. We see that we have feet become singular and gives us an idea of what we're doing. Now we can move on to the lemonizer. So what I'm doing so far is I'm looping through this and going instead of our list, since we have, I think it's triple nesting, it's pretty crazy. So I'm putting off J, and so what J is really doing is we have our list of lists, and then I'm verifying each one of these entries within the list. Alright, so what I did here was take the index position so I could keep track of everything. What is going on here? Oh, okay, yeah, sorry, it threw me off. So I have the index position in each word that's occurring inside of it. Alright, so if you notice, we got rid of the S, which was for today's, but if you see something here, this is two words that end up not getting split on a space, so we have to deal with later. Interestingly enough, exists. We didn't have to get rid of that S, which is interesting. Now we will use a default dictionary list to put each one of these keys together with these lists of values. There you go. Let's throw this into a data frame real quick and see what this looks like. Create a new column here. Scroll over to the end, and there we go. If we wanted to save this for later. But let's look at correcting some spelling mishaps. For instance, if we had happening, morning, window, and jacket, and they were spelled wrong, let's see how we could handle this, as well as the first entry in our new dictionary that we have. So for instance, we're using the text blob import, and what I'm doing here is checking to see through a comprehension if this is valid or not. Spelling. And there's a few things you need to look at. Doesn't drops the T, which is interesting. This speaker as becomes speakers, so it's getting confused and thinking that we're dealing with speakers. We also have this right here, which is suppose but, which needs to get split as well. So it could detect if we have some words that are misspelled, but it cannot detect if we have other issues. Alright, and sometimes it may confuse a word and think that it's something else. So let's try to take care of words now from some code I found right here on Stack Overflow, if you just want to look at this last portion here in Google. And I found this. There's a guy who, I guess he's very well known in his field. You click this link and he has some books and libraries that handle this kind of thing. I'm not going over this function. It is not mine, like I said. But what we're doing here, and it runs very slow also, as a side note. So let's see if this prints out. So what I did was put together three words here and see if it would figure them out. And it looks like it split off these two that are from our actual data, this that I just made up. And it assumes that, hey, this might just work for us. But there's always going to be use cases that are incorrect. And let me show you what's going on. So I iterated through this function from above, segment. Let me show you something. We have Facebook, which is a company which can be two words, but it's getting split. And for instance, it doesn't know how to anticipate apps, which is basically, I don't know if you call it an abbreviation or shorthand notation for applications, but it's splitting it to individual letters because it doesn't know. And that's not really what I want. And the only ways that you can really deal with this is building a custom dictionary that takes care of this. But the only way to take care of it is to work off an actual data set that you're evaluating currently and expand that dictionary. That's something you need to take note of. Let's look at this. I decided to see if we could work with that from above, and noticing that inside my data set there were a few words that were two words, but they forgot to separate by a space. That's why I did this, and saying if the length of the word equals 2, not more than 2 after it's split only 2, such as this, let's see if we could find a way to map this correctly. So I built this code block, and what I'm doing is I'm looking inside of each one of these. If this entry right here is 0, basically just append it as 0 with this index position. Otherwise, if you have one of these lists with these strings, do a string join and actually do a import of words from the Nltk corpus, which is going to evaluate if this is a real word or not. The issue with this is not all of these words are in the corpus. Therefore, you would have to create a further dictionary. Nevertheless, if you have some words that evaluate to false, meaning it's not in the dictionary, then just append the 2 words that are in your list with the index position. Otherwise, if it is a real word, append that joined word and its index position. Let's look at this. And this had some issues. Let me explain why. This will take a sec. One of the other things, if you had millions of things to compare, this would just not work. Now, speaker as is correct. Suppose but is correct. Don't was left alone, but neural link got split. This is something that Elon Musk was talking about. That's what this entry was from. Then you have IO. Okay, fine. But then the name for Siri, hey Siri, can you find this for me? That was split. And this is a company name right here. That was split. And this is a company name. So how do you deal with this? Create your own special dictionary. Now, let's look at something. Okay, so I have this list of words and I was evaluating this so you can see what's up. So I have suppose as, but it's not in the corpus of the Nltk words. All of these are false until you hit suppose. This is there, but it only works on the word that's spelled correctly. It doesn't work off of edit distance, Levenstein distancing, those kind of things. Also notice the fact that you can have don't with and without the apostrophe. Without the apostrophe, that's a valid word. As soon as you add that conjunction, it's false and it doesn't work here. And there's other packages that you can look at. I found one last night but have not used it. That deals specifically with conjunctions if you were to spread those out and increase your corpus for whatever you're working on, if that's necessary. But I just wanted to do a brief rundown so you could understand some of the hiccups and things that you will encounter if you start dealing with NLP data, or if you've been introduced and you don't have an idea about some of this. Please like, share, and subscribe. And if you subscribe, turn on that notification bell. I hope this brought utility to someone. As a side note, I have a great deal of really cool articles and things to read in this file, in the citations, as well as if you go on the GitHub, PDF textbooks you can start looking at. Have a good one. Bye.